Follicular dendritic cells, Wikipedia audio. Follicular dendritic cells are cells of the immune system found in primary and secondary lymph follicles of the B-cell areas of the lymphoid tissue. These cells were first described in 1965 and, although they have a very dendritic morphology, are not dendritic cells. Unlike DCS, FDCs are not derived from the bone marrow hematopoietic stem cell, but are of mesenchymal origin. Follicular DCS are a non-migratory population found in primary and secondary follicles of the B-cell areas of lymph nodes, spleen, and mucosa-associated lymphoid tissue. They form a stable network due to intercellular connections between FDCs processes and intimate interaction with follicular B cells. Follicular DCS network typically forms the center of the follicle and does not extend from the follicle to the interfollicular regions or T-cell zone. Supposedly, this separation from the sites of earliest antigen processing and capture provide a protected environment in which opsonized antigens can be displayed for a long time without being proteolyzed or removed by phagocytic cells. Follicular DCS have high expression of complement receptors CR1 and CR2 and Fc receptor FCRIB. Further FDC-specific molecular markers are FDCM1, FDCM2, and C4. Unlike other DCS and macrophages, FDCs lack MHC class II antigen molecules and express few pattern recognition receptors, so they have little ability to capture non-opsonized antigens. Follicular DCS develop from putative mesenchymal precursors. Severe combined immunodeficiency mice models demonstrate that these precursors may be transmitted to recipients with bone marrow allotransplants, in which case both donors and recipients' FDCs networks may later be found in recipients' lymphoid compartments. Interaction between FDCs precursors and lymphoid cells mediated by TNFA and lymphotoxin is crucial for normal FDC development and maintenance. TNFA binds on the TNF receptor, while LT interacts with LT beta receptor expressed on FDC precursors. In mice lacking B cells, or with blocked TNFA and lymphotoxin production, cells with FDC phenotype are missing. Location and molecular markers. In normal lymphoid tissue, recirculating resting B cells migrate through the FDC networks, whereas antigen-activated B cells are intercepted and undergo clonal expansion within the FDC networks, generating germinal centers. FDCs are among main producers of the chemokine CXCL13, which attracts and organizes lymphoid cells. Follicular DCS receptors CR1, CR2, and FCRIB trap antigen opsonized by complement or antibodies. To become selected as a future memory cell, GCB cells must bind the antigen presented on FDCs, otherwise they enter apoptosis. By secreting the bridging factor MFGE8, which cross-links apoptotic cells and phagocytes, FDCs promote selective debris removal from the GC. Factor MFGA produced in lymphoid tissues mainly by FDCs is known to enhance engulfment of apoptotic cells. Deficit of this factor in mice leads to a state resembling systemic lupus erythematosus. Furthermore, mice lacking LT or LT receptors, which are devoid of FDC, develop generalized lymphocytic infiltrates, which are suggestive of autoimmunity. These findings suggest that FDC possibly protect organism against autoimmunity by the removal of potentially self-reactive debris from GC. Non-cognate B cells play a significant role as an antigen transporter to FDCs. They capture immune complexes in CR1/2 dependent way either directly from the blood or from macrophages, and putate to the lymphoid tissue, where they upload FDCs with opsonized antigen. FDCs, in turn, attract B cells with chemoattractant CXCL13. B cells lacking CXCR5, the receptor for CXCL13, still enter the white pulp, but are mislocalized and disorganized. To generate follicular structures, FDCs need to be stimulated by lymphotoxin, a mediator produced by B cells. The stimulation of CXCR5 on B cells upregulates LT production, which leads to FDCs activation and stimulates further CXCL13 secretion, thus generating a positive feed-forward loop. This results in the formation of GC, where antigen-activated B cells are trapped to undergo somatic mutation, positive and negative selection, isotype switching, and differentiation into high-affinity plasma cells and memory B cells. Adhesion between FDCs and B cells is mediated by ICAM1-LFA1 and VCAM-VLA4 molecules. Activated B cells with low affinity to antigen captured on FDC's surface as well as autoreactive B cells undergo apoptosis, whereas B cells bound to FDCs through the antigen complex survive due to apoptosis blockage caused by interaction with FDCs. Rare primary FDC tumors have been described. These sarcomas often involve lymphoid tissues, but in a number of cases the tumor has been found in the liver, bile duct, pancreas, thyroid, nasopharynx, palatum, submucosa of the stomach or the duodenum. In a number of chronic inflammatory conditions, cells producing CXCL13 chemokine and carrying such FDCs markers as VCAM1 and CD21, have been observed at quite unexpected sites, including synovial tissue of patients with rheumatoid arthritis, salivary glands of patients with Sjogren's syndrome, and the skin of patients with pseudo-B cells lymphoma. Follicular dendritic cells participate in HIV-1 infection development both by providing a haven for HIV-1 and by stimulating HIV-1 replication in adjacent infected monocytic cells via a juxtacrine signaling mechanism. There are also some evidences that FDCs may promote prion replication and neuroinvasion in neuroinvasive scrapie. Development. Functions. Organizing lymphoid microarchitecture. Antigen capturing, memory B cell support. Debris removal. Preventing autoimmunity. Interaction with B cells. Diseases.